Hello everyone, my name is John Sayer, Technical Marketing Manager, Civil Infrastructure here at Autodesk. Today I would like to walk you through one part of the scan to BIM workflow. We will begin with Lidar to design. This process will start off with raw scans from the field that we bring into Autodesk Recap Pro. Then we will take the process point cloud into Infraworks and create a surface so that we can run linear feature extraction. From there, we will bring the linear features and the surface from Infraworks into Civil 3D so that it can be used for design. So let's get started. So where do we start? We've been provided some LAS files from a scan of a road in and around Atlanta, Georgia. So let me show you those real quick. Here in my dataset folder, I have the original LAS files. So these LAS files are all set to a coordinate system, and that coordinate system is GA83-WF. Right, so that is a very key thing here whenever we're trying to put these LAS files or convert these LAS files to RCP files or a recap project. So let's go ahead and create a project here in Recap Pro and let's import these LAS files real quick. I'm going to create a new project, so I'm going to select New Project and we'll use the Import Point Cloud selection. So my project files are actually going to be out here underneath my data set. So I can just go out and select, or just select the folder I wanted to drop into. So that's going to be this Lidar to Design folder. All right, and I will give it a project name. All right, so we're going to call this Georgia Roadway. And I'll hit Proceed. All right, once we built the project, we're now going to bring in the LAS files that we were provided from the field. So I'm going to select Files to Import. And I'll go out here and select original LAS files. This is my folder where I've got the files themselves. And I'll grab all of these LAS files and hit open. Some key things we need to remember here. We don't want to just hit import files here. We want to make sure that we select advanced because we need to set the coordinate system. All right, I said that these were all in GA83-WF, which is Georgia Nat 83-West Zone US foot. All right, but we need to make sure that we set that here. All right, if you don't, then what's going to happen is it's going to come in the wrong position. So I'm going to go ahead and select in here where it says current. And I'll go ahead and type in GA83- and it gives me all of the GA83 selections. So I'm going to pick WF and OK. Now that's the current coordinate system. We need to set the target coordinate system to the same. So I'll just go ahead and type in GA83- and we can again pick GA83-WF. I'll hit OK. I'll go ahead and hit Import Files. So what it does is it converts the LAS files into RCS files. It also creates an RCP file that basically holds the collection of the RCS files that are generated from each one of these LAS files. So we'll be looking for the RCP file to bring into Infraworks. But there are some other things that we want to do inside of Recap because I may not want this entire project. So what I'm going to do is just open up the RCP file that's generated, and then I'll go ahead and grab the area that I want. So this will take some time to process. So I'm going to go ahead and open up a project that I've already processed with all of these LAS files. So it's already converted into the recap format so that I can start to utilize it. So I'm just going to suspend the project and I'll select a project that I've already processed. All right, so I know that the area that I'm wanting to work with is right in this area right here. So how do I filter out just the area that I want? Well, inside of Recap Pro, we can create a window of the area that we want. All right, so I just want this area right here. All right, so what I will do is just create a region from this area. So I'll select region and then select a new region. And we're going to call this design area. You can call it whatever you need to call it. All right, it just defines it differently than the overall point cloud. Once we define our region, then I can hit clear and it'll clear the dialog out. And I could go over here to my project navigator and I can select the scan locations. All right, so these are the scan regions This is the set of scan locations. So this is each individual scan as you see it. So you can actually select this button and it will zoom you to that particular scan location. Right? But we're going to be worried about these two regions. So we have unassigned points, all right, and we have our design area region. All right, so if I was to turn off my design area region, then everything else would show, which is all under unassigned points. The design region is the region that I want to export out and bring into Infraworks to create a surface. So I'm going to go ahead and turn off the unassigned points. That leaves me inside of my model with just the point cloud information that I'm wanting to work with today. You could either bring in the entire point cloud and generate a surface from the entire point cloud, or if you only have one area like I'm showing here, you could just bring in this point cloud and it'll keep your model from getting too large. That doesn't mean you can't generate a surface from the entire point cloud, because you can. I just wanted to chop out a piece of the point cloud so that we could create linear features and things of that nature on just this one area. So I can go up to the home button here and I can drop down and select export. So if I select export, it's going to bring me out to my particular folder. So I need to navigate to my dataset folder. And I'll go ahead and pick my Lidar design. And I'm going to just drop it here in the root directory of Lidar design. So what I wanted to break out is an RCS file. I want a single RCS file. And this is just one way to do it. We can actually export out, if you look here, we can export out an RCP, an RCS, a PTS, and an E57 file. We're going to export out an RCS file. So we're going to call this design area. I just name it the same thing as I do my region, and that's totally arbitrary. You can name it whatever you want. And I'll hit save. Now the first thing it's going to do is ask me if I want to unify my scans. So it wants to unify all of the individual scans that I'm showing here in this region so that it can create one RCS file. So I'll hit let's go and unify my scans, and we'll wait for this to export the project out. So now that we've exported our RCS file, I can simply go up to the home button and I can save my project, or I could do a save as. So I'll just go ahead and hit save, and we will close recap. Now we're ready to jump into Infraworks and create a surface and pull linear features from the point cloud. Now that we have our point cloud filtered down to just our project area and exported out, now we're ready to go into Infraworks and bring this point cloud in and generate a surface from this point cloud. We don't necessarily want to bring in the entire area that was actually driven by the person in the mobile LiDAR, or with the mobile LiDAR. So I want to create just a project area that just encompasses this particular part of the clouds. When I say create a project area, I mean create a model in Infraworks of just this area, okay? Now again, I could create an area of the entire that would encompass the entire point cloud, but I just want to work with this one particular area. So a good way to do that is to open up Civil 3D, and we're going to first open up a brand new drawing. This is just a plain Jane drawing, all right? And we're going to set the coordinate system. All right, and that coordinate system is going to be set to GA83-WF. All right, we'll hit apply and OK. All right, and once we have our coordinate system set, we're going to save the drawing. All right, so I'll just save it out here. Flip it into this Civil 3D folder. All right, and I'm just going to call this design area. And I'll hit save. All right, now, after I've created my new drawing with my coordinate system set, I want to go to the Insert tab on my ribbon, and then I want to go to Attach under Point Cloud. I'm going to attach after I change my file of type to RCS, because the file that we exported out was an RCS file, not an RCP. All right, so I go to where I exported that particular file out, and I select it. Remember, we called it Design Area. And I hit Open. All right, being sure that all of this is unchecked except for Zoom to Point Cloud, I hit OK. And it brings my point cloud in. Now to check the location to be sure, number one, that it is actually in the right location, I can go to the geolocation tab and I can turn on my Bing map just to take a look and make sure that everything's okay. And I can see here that this is in the correct location. All right. So an easy way to just create an Infraworks model of just this smaller area, because this particular point cloud actually follows way up this highway, turns, comes all the way back, so on and so forth. So it's a rather large point cloud. It's a rather large area. So I'm just going to create a rectangle here inside of Civil 3D, all right, of just this area. And that'll be the area of interest that I select whenever I go into Model Builder in Infraworks to create my model. So how do I get this out to bring it into Civil 3D? I'm just going to run what's called map export. And what I'm going to do is I'm going to actually export out a shapefile. All right. And we're going to go out here and dump this shapefile in the same folder structure that I've been working with. I'll go ahead and just build a new folder called boundary. All right, you could have called it Infraworks boundary. I'll give it a name, or I'll just call it boundary. All right, I'll hit OK. I'm going to select the object type. It's going to be a polygon because it's a rectangle here. And I'll select it manually from my screen. And I want to be sure here that it says one object selected and that there's 0 filtered out. All right, because if it says one object selected, one object filtered out, I need to go back and check on why that would be filtered out. All right, but it's just a regular AutoCAD entity. It's just a rectangle. It's a closed polygon, so it should be very easy to export out. So here in options, I'm going to go ahead and tell it to treat those closed polylines as polygons, and then I'll just simply hit OK. Now I have a boundary that I can actually import directly into Model Builder, and it'll bring me to this exact location, so I don't have to try and find where I want to build my model here in Infraworks. So let's jump over to Infraworks here and go ahead and select Model Builder. There's several different ways that we can actually select the area that we are wanting to create a model from. So the way I'm going to do it today is I'm going to use that shapefile that we created in Civil 3D, and it's going to import a polygon to select an AOI, which is an area of interest. So I'm going to select that button there, and I'm going to select, you can see that it's scrolled out to where I house that boundary file. I'm going to select the shape source and the OBJ file. All right, and I'll hit open, and you can see it goes right to the area that I am wanting to work with. So I can turn on my aerial map if I want to kind of match it up to what I looked at in Civil 3D. All right, I'll go ahead and give it a name. We're going to call this Atlanta Roadway Design. I'll call it Lidar. And we need to put it in a folder in BIM 360. So we're going to drop down. I created a project inside of BIM 360 called JS Lidar to Design Use Case. All right. And under that, I've got project files, and I've got a folder under project files. It's called Infraworks Model. I'm going to add that to that particular folder. And I'll hit Create Model. And it's going to go out, and it's going to create my Infraworks model for me. So I'll close the Model Builder, and we can see that it populates here on my home screen. So I'll go ahead and select my newly built project, and it'll open the model. So here we have a brand new model of just the area that we were wanting to pull from that particular shapefile. So this is going to be a fairly lightweight model, and we'll be able to create information inside of it and work with it very easily. So remember in Recap Pro, we exported out just the area that we wanted to work with here for this project. So let's bring in that point cloud and take a look at it. So I'll go to Windows Explorer, and you can see here I've got that design area RCS file. So I'm just going to drag and drop that onto my model. All right. Couple things to look out for. Be sure that if you drag this onto your model and the first thing you see here is your coordinate system and it doesn't say the coordinate system that is correct, which in this particular case it was GA83-WF, then you probably have a little bit of an issue with the export, so you're going to want to go back and re-export that point cloud. But it's set up correctly here, so it's the exact coordinate system that we used. So I'll go ahead and hit close and refresh, and our model will populate with that point cloud. So I'm going to zoom in to that area, and you can see that the point cloud's kind of laying on top of a lot of this other information. So what I'm going to do is I'm going to generate a surface from this point cloud here in Infraworks, and that's going to help it. Number one, it'll help us to see it visually a little bit better, and we'll be able to see where we need to pull linear features, things of that nature. And I'm going to clean up the model just a little bit here. First thing I want to do is I want to create a new proposal because I want to leave my information intact that came in from Model Builder. So that proposal is called master. I'm going to drop down and add a new proposal. We're going to call this surface. Hit OK. And it generates a new proposal called surface. Now this is the proposal that we will generate the actual surface from our point cloud in. So I'm going to go back over and build, manage, and analyze your infrastructure model tab. And then I'll select create and manage your model. I'll drop down and select point cloud terrain out of that menu. Now you can see here that it shows our point cloud name that we imported. So you can see design area. Remember that was the RCS file name. Now I'm going to leave all of this set to optimum under our processing rules. This allows for the best surface and the best way that it classifies our point cloud. If I get a surface that doesn't look like what I need, or you think maybe it needs to be weeded down a little bit more, you can always go through and get a little bit granular with each one of these different controls, like for ground, linear feature, and vertical feature. But for now, I'm going to leave this to optimum. We could have it generate a lightweight point cloud for us that's not got all of the features inside of it, and export that actual point cloud out as a separate RCS file. But we're going to leave that option off today. So we're just going to go ahead and select Start Processing. Now what it's going to do is it's going to go through and process and generate a surface, but it's going to classify the point cloud first. Now that the surface is built, we can see here under Terrain in our Data Sources dialog that our design area has been generated. The terrain for that has been generated. So now we're ready to pull some linear features. So we're going to use what's called linear feature extraction here inside of Infraworks. So my project start is going to be here in this area right here, and we're going to run all the way down to where we run out of point cloud down here. Now my terrain overlay is on, so I'm going to go up into my Model Explorer, and I'm going to turn off that terrain overlay so that I can see my point cloud just a little bit better. All right. Then I'll zoom in to where I want to start creating my linear features. So I'm going to go over here in the same menu area to linear feature extraction, being sure that the mode that it is in is automatic. So we could create manual linear features, or we could create them automatically, and I'm going to generate them automatically. So I'm going to start off by creating a linear feature for this center line. So I'll change my style to the paint stripe linear feature, and I'll go ahead and just select one of the paint stripes and then pick the second paint stripe. Once we hit escape, we can see that the linear feature ran as long as it could see inside of that point cloud to where the paint stripe was that we selected. So we just selected the dashed line, and then it splits off here and stops back here at this area. We're not concerned with, at this particular time, that it goes that far, because we're going to stop it right in this area where the lanes start to divide. So if I want to, I can actually select the linear feature here. I can right click and I can select that I want to split this feature. All right. Then if you see, if I select the feature after that point, it's like it broke it. It's like using an AutoCAD break command. So I can just grab that top linear feature and I can hit delete, and this is where I'll stop my particular generation for this job. So now I need to create linear features for the edge of pavement. All right, so the edge of pavement stripe is right here. So I would actually just select and change the style to this edge of pavement feature. I'll zoom in here and I'll just select at a starting point here, and I'll double click here, and it will create the linear feature for that edge of pavement. And you can see that it generated here our linear feature. It went way past where our project limits is up here. You can see where it actually splits off, and it continued on down the left side lane that splits off to the left there. So we would just break that again if we wanted to. We could just break it right here. We would then continue to generate linear features for everything that we wanted to represent inside of our design. So we would build one for the edge of pavement here, and then I might build some for this barrier here. Now that we have the paint stripes and the edge of pavement located with our linear features, and we've extracted those lines at the length of what our project would be, we can then select this center line here, and we can create a cross-section view and take a look at the cross-section of the actual point cloud itself and the surface that it's generated. So I can select Show in Cross-Section View, and I can take a look here. And just to go through a couple settings real quick so that we can see, we can bounce down this center line at an interval that we'd like to. I'll go ahead and hit the settings wheel. And the interval that maybe I'd like to go down that line would be every 50 feet. And I can change the thickness. That's the thickness of how this is shown right here in the cross-section view. So I could say if I wanted to increase that, I could make it 5, and it'll make it a thicker line here so that you can see it. I'm going to leave that back at 2. I like that thickness. And this auto vertex cleanup, we can leave that on. And you can see here that we have our center line, our edge of pavement on both sides, and we've got a barrier, a jersey barrier here on the left-hand side. Now, I'm going to go ahead and close the settings here, and then I'm going to hit the plus sign right here, and it'll take me to the next even 50-foot station. So I can definitely see that that barrier is here. If I keep bouncing down that line every 50 feet and sampling that line every 50 feet, I definitely see my linear features that I've extracted and my center line, and I see this barrier. Well, I would like to actually include that barrier in with my linear features. So what I can do is at station 50, I'm going to go in here and I'm going to create a break line of my own. So I'll create a break line here, and I'll create a break line at the top of the barrier. So in order to do that, I can right click and hit Add Vertices, and I can just pick one of these 3 break lines here. So I can hit break line 1, and what I would do is I would grab and drag that down on the cloud or on the cross-section view where I would like it to be. All right, I'm going to right click and add another vertice, a break line 2, and I'll grab it and put it at the top of the barrier. Now, I could get as intricate as I wanted. It's showing this barrier very well, so I could actually set another point right here as a break line, and I could set one at the back. But for today, we're just going to do the top and bottom of the barrier. All right, so I can zoom back and look at my cross-section view again. All right, now I'm going to move this window to the left, and watch over here on top of that jersey barrier. If I hit the plus sign, it starts to draw those feature lines for me. So there's the top of the barrier. So I would zoom in and make sure that these break lines are sitting at the correct location, and if they're not, then I can grab them and move them over to the correct location. I'll do the bottom of the wall also. All right, and then I just simply hit the next 50-foot station, and it draws that feature line also. So you can see this is off just a little bit. So I can go back and move them back to where they need to be. All right, I can go ahead and hit the next 50-foot station. So I'm going to go ahead and continue to do this for the length of our construction project here. And then we're going to talk about transverse features and the benefit of transverse features. So you can see here at the end of the feature line, it does tell you here that you are at the end of the feature line. You can see that this wall has gotten a little bit higher, and it's not really a jersey barrier anymore. It's more of a retaining wall of the fence. So what I did was carried the bottom elevation of the wall through with that same break line 1, and then I used the top of the wall here where the fence starts, and I just went ahead and carried that break line 2 through with that. Now, you could have done this any way you wanted. You could have stopped at the Jersey barrier where it stopped completely and started a new break line. Or you could carry it through like I did here in the demonstration. It's totally up to you. You have that leeway of being able to do that. Now, let's go back to the very beginning of our project here. All right. And I can see that I do have my linear features for my wall. All right. And it does look like underneath that the linear feature is not there for the bottom of the wall, but it is. It's sticking there at the bottom. So that those linear features will be at the correct elevation. All right, so now what we need to do is create some transverse lines or transverse features. So if I select that center line again, I right click and I select generate transverse lines. So it could be transverse lines or transverse feature lines. They'll be referred to that a couple different ways. I mean, they're the same thing though. The generate transverse lines is what we want to select here. Now, what this is going to do is this is going to create a set of lines from the beginning of this feature to the end at an interval. All right. So if we look at the dialog here, it's asking us for a line length, a distance between lines, and a distance between vertices. So these two different features here, or the two different settings here, this works much like a cross section does in Civil 3D. So for this particular line, I know that if I go 70 feet, that's going to be plenty of capture across this cloud. All right, so that's the distance it's going to sample across this particular piece of the cloud or wherever that station is along that line. Now the distance between lines, this is the sample line increment basically, and you can set this to whatever you want. I mean, if I want to take it down to 1 foot, I can do that. All right. What are we going to use these for? Well, we can use these transverse lines to generate points along that line from the point cloud that are on an interval. Like this is set to 25 feet, so every 25 feet it would sample that cloud, and you would have a space between the points on that line every 3 feet. So there'd be a line 25 foot ahead here, and that particular line, it would extract points every 3 feet along that line. Now I like to bring this down to about 2 feet so that I pick up more of what's there vertically. And I'm going to leave this distance between lines every 25 feet because that's a good sample line distance. Now, if there was a lot of vertical change or there was things going on or this road was really potholed or anything like that, then you could change this distance and it would create, or change this distance between lines, and it would create a much tighter sampling. All right, but we're going to leave it at 25. Now, what are we going to do with these lines? I'm going to go ahead and hit OK. And it's going to generate those lines. What are we going to do with these lines? We can bring these lines into Civil 3D. And when we generate a surface, or we bring the surface in from Infraworks, we could generate that surface one of two different ways. We could actually generate a lightweight surface from these transverse features, or we could actually use them as break lines within the existing ground surface that we bring in from Infraworks. We could do the same thing with the linear features here that we've added inside of the Infraworks model. So the top of the wall, the bottom of the wall, and the paint stripes for edge of pavement, and the center line. Now, once these transverse features have been built, I can simply hit Escape, and I can go over and I can export out all of this information at once. All right, so I can go up to Export Point Cloud Extraction. A few things you need to understand. We could actually export out just the ground grid points only. All right, we're going to take that off because I'm going to bring in the surface that it generated from Infraworks to populate Civil 3D. And then I'll bring in the linear features here. It will create a shape file for these linear features. And then I want to bring in the transverse features, and they're going to come in as a CSV. All right, so they're going to come in basically like a point file. Now the vertical features I'm going to shut off because I've not extracted any vertical features. And the last thing, or actually not second to the last thing here, this target CS, the target coordinate system, be sure that this is set to that GA83-WF, or the coordinate system that your Infraworks model should be, or the coordinate system that the point cloud is in, okay? So make sure that this target coordinate system matches that point cloud coordinate system. Then you want to just select a save folder. So I'm going to pick here, I'm going to navigate out to my folder system again, and we will dump this in a folder called LFE data, all right? And I'm just going to hit select, and it's going to push that information out. All right, so we simply would hit export at this point, and it's done. Export point cloud extraction features are complete. We hit OK, and now we're ready to jump over to Civil 3D in our design environment and start to utilize this information from this point cloud directly out of Infraworks. Before we jump into Civil 3D and start to look at how we can start to work with the linear features and things of that nature in design, what we need to do is go ahead and sync this model with BIM 360. So not only is it saved for us in the cloud, but we're able to start collaborating with it with other stakeholders. And there's a lot of great things that we can do in BIM 360. So let's just walk through it real quick. So the first thing we would do is we would want to sync the model itself. So I just select my sync button here, and it will communicate with the cloud services. And you can see that there are a couple things that need to be synced, and there are changes to this model that have not been synced with the cloud in BIM 360. So first thing I want to do is I want to show you what the model looks like in BIM 360 before we actually sync it. So it's this Atlanta roadway design Lidar file. You can see that it is a version 3, so I have synced the file and there are some changes up there, but we need to sync it again so that this number will actually change to V4, so it'll be the 4th version of this. And we want to go ahead and be synced to the cloud before we start to look at it in BIM 360 in the Autodesk viewer in Google Chrome. So I'm going to go ahead and simply hit sync, and it's going to synchronize this model. And it will go ahead and tell us here after it's done syncing that it has synchronized the model, and that if you want to manage, collaborate on the model in the cloud, that you can then open up BIM 360. So let's do just that. So we're good to go here. I could access it right here by selecting Experience Your Model in BIM 360, but I've got this in Google Chrome right now, and you can see you do have to wait just a little bit in order for it to go ahead and sync. So what it's doing is processing right now. You can see it already says V4, but it is still processing if you're seeing that spinning circle. So we'll wait for it to go ahead and stop spinning before we access the model. Now that the model has been synced to BIM 360, we can actually just select the name of the model right here, and it will open it up inside of Google Chrome in the Autodesk viewer. Now, once it regenerates, typically what you will see is the original layout, meaning the proposal that comes in Infraworks called master, and we can change to the proposal that we want simply by moving over here on the left from our selection here on the left, selecting sheets and views, and then I can pick the proposal that I want to look at. So I'm going to pick that LFE finished, and it's going to regenerate and show me that model. Now you'll see everything here once it populates except for the point cloud. The point cloud is not supported yet, but we can zoom in and we can take a look at the model and look at the different features that we have actually in here. So it does show the linear features. You can see that it shows the transverse lines, so we can actually list those and take a look and see what they are. We'll do that here in just a minute. So first off, I'd like to talk to you a little bit about what you can do here inside of BIM 360. So we'll just kind of move across the bar here. We can start by, if I select orbit, I can actually orbit the model around. So it's just a good way to navigate and get to where you want to be. So I can orbit around, select orbit again, and then I can zoom in with my wheel. I can push my left mouse click down and move around in orbit, and I can right click on my mouse and pan. All right. If I want to get a different view of looking at things here in the model, then I can select this first person tool and I can move around with my arrows on my keyboard. So we'll take a look at that. We'll just move around just a little bit. And then if we want to run, we can hold our shift and then direction key. So I can hit got it here and it'll drop me down to the top of my surface. All right, once I'm on the surface, I can actually pan back up with my left click. I can move back up to where I'm looking down the road, and I can hold my arrow down and I can move down the road. Now, if I want to run, I just hold my shift key down and I can hold my arrow and I move faster. Then I can move left and right. So I can look at the transverse features, I can look at the linear features that were pulled, so on and so forth. Now to get out of that, I just select first person tool again, and then I can pan around and orbit, free orbit. Now I can do this also. So I'm gonna zoom window right here where I can get pretty close. And I'm just gonna pull a distance with my measuring tool. I don't want to necessarily pull a distance with meters, so I want to make sure it's set to decimal feet. All right, and then I'm going to just pick a point here. All right, and I'll pick a point here. You can see I didn't get exactly on it, but those were spaced inside of Infraworks every 25 feet. So that says that's the correct distance. All right, now I can go back up to, or actually I can open my model browser and I can turn on and off different features inside of BIM 360s with the Autodesk viewer. So I can just turn off the buildings. I can turn on any constrained features. I can turn on and off linear features. I can turn the roads on and off. I can turn water areas on and off, so on and so forth. Anything here in the model browser, I can turn it on and turn it off. All right, so I can close that. So the last thing that I'm going to talk about here inside of BIM 360 is I want to talk a little bit about being able to look at the properties of things. So if I use my zoom window here and I zoom into this area and then I go ahead and turn on my properties here, if I select like this particular linear feature is selected, it gives me the feature code that I set whenever I was in Infraworks when it pulled the line. So I can just go through these and I can see this is a paint stripe. This is an edge of pavement marker. I can click on the surface, doesn't have any particular information on it. EP is for edge of pavement. If you remember, I had this wall. I didn't set a number to it or any kind of description. That was a break line that was in here. I could select my transverse line and it would tell me that that's what that is. That's what TR stands for. So anything that has properties, so I'll select that building and it tells me the ID for that building, the roof height, so on and so forth. I can select this road and it tells me, you know, the information that's on the road. So it's a motorway, things of that nature. So I said looking at the properties was the last thing, but the last thing that I need to talk about is the fact that we could create a markup. So I'm just going to add a new markup and we'll just put a rectangle around the area and I'll say this is, I'll put some text in here and say this is the beginning of LFE. All right, so I can hit done. All right, and this is what it will look like in the markup. Now I can hit exit markup view and I don't see it anymore. But if I move over here to the left and I select my markups, I can look at that again. So all I have to do is select that markup and here it is. All right, if I exit out of the view again, I can then publish that view and it would publish to everyone that's in this project as a project member. All right, so I can just hit publish and now everybody would be able to see this particular markup. Also, if I close that window and then I close the actual model, you can see that it does have markups here. You can see that in the web browser of the document manager portion of BIM 360. So now that we've synced our model to BIM 360 and looked at what we can do and how we can utilize BIM 360 to view and collaborate with other stakeholders, let's move into Civil 3D and see how we can use the information for design. Now that we're here in Civil 3D, we can start to leverage some of the information that we've pulled from Infraworks and generated from Infraworks meaning the linear feature lines, the transverse lines, and the surface that was generated inside of Infraworks. We can pull all of that information into Civil 3D directly from the Infraworks model. Actually, the surface we can bring in from the Infraworks model, but we're going to utilize the shape files that we generated, the linear feature shape files, and the transverse points that came from the transverse lines that we generated. And that way we can start to create a design model inside of Civil 3D. The key point there is, though, that a lot of that information, or all of that information, is coming from Infraworks. So I created a new drawing here, and in a previous video, I created a drawing in Civil 3D so that I could geolocate myself and create a boundary, basically, for Model Builder to narrow down the area that I wanted to build the model out of. So I could have used that drawing, all right? I could have just detached the point cloud and turned off the geolocation, and we could bring that information in and look at it in that drawing. But I wanted to start from scratch here and go through those steps one more time. So I've created a brand new drawing. I'm going to select settings here, and I'm going to actually set the coordinate system to the same coordinate system that we've been using, the GA83-WF. WF. Hit apply and OK. We're going to save that drawing here in our same file form or file location that we've been using, and under Civil 3D, and I've got the one that I created before called Design Area. I'm just going to call this Master Design because this is where we're going to start to do our design in Civil 3D. I'll hit save. You could have named it whatever you'd like. I'm going to go ahead and attach myself to that Infraworks model so that we can start to pull that information in. So I've still got Infraworks open here. One thing you need to be aware of is that in order to attach to an Infraworks model and bring the information in, Infraworks needs to be closed, or the model needs to be closed. So you could do that a couple different ways. While that's shutting down here, I'll explain it. You can just shut Infraworks down like I did, and it will release the model. Or you could actually go back to the home screen and open up another model, and it will actually release the model that you were in, and then you can open up the model here in Civil 3D and pull information across. Best way to do it is just to shut Infraworks down, and then you know everything's closed. So once the model is closed, I can go to the Insert tab here on the ribbon, and I can pick my Infraworks button. I can hit Open Infraworks Model, or I could select Autodesk Infraworks, and I could pick Open Model. And I'll select that Infraworks model that we just closed, Atlanta Roadway Design Lidar. So it sees that the drawing in Civil 3D is GA83-WF, and the Infraworks coordinate system default is LL84, but it will come in the correct location. So I want to refine down what I want to bring in from the model. I just want to bring my surface, all right? I could reduce the area of interest, meaning I could select area of interest and then hit select area, and it would give me the area of my model, okay? So again, this is what I pulled from Model Builder, and this is the area of my model from Model Builder, but I don't necessarily need all of that area. All right, so I'm just going to hit escape here, and I'm just going to say the extents of the Infraworks model, and then I'm going to refine my selection. So it's going to have roads and bridges and all kinds of things in there that was inside of Infraworks that will actually come through, and I'll show you that here in just a second once it attaches to the Infraworks model. We don't necessarily have to have all that information come in. We can just select the surface to come in and go from there. So as you can see here, this is all the information that we could actually pull in from that Infraworks model. So we have terrain surfaces, planning utilities if we had any, our planning roads. Of course, we've got a whole lot of planning roads in that one area. This is Atlanta. So I can scroll down and I can look at all that. We've also got water areas that we could pull in. So what I like to do is I like to collapse the tree, and then I just take all the check marks out, or I can hit this clear all button, and then I just want my AIW existing ground surface. All right, that's all I want to come in. So I hit OK, and then I hit Open Model, and it will bring in the surface including my point cloud for that entire area. Now, I could have refined the area that it brought in, but I didn't necessarily need to. I know that this is the area here where my road is. All right, so I could bring the point cloud in and verify this, and it would not be a problem. Another way to do it would be to bring in the linear features. I can also, after I get my linear features in here, I can actually create a boundary around this surface and then know that I have just the area there that I need. So the first thing I want to do is I want to bring in my linear features that I extracted. So in order to do that, I'm going to use the map import command. So I can just type map import, and I can scroll out to where my data set's at. All right, and that's under the LFE data. This is the shapefile that we exported from Infraworks. So I hit OK, and I go to look at the data. I make sure that the coordinate system is correct, and it is. And I don't have to really do anything here except for hit OK. And my linear features come in. All right, now this was from the point cloud itself, so the Bing image is going to be shifted just a wee bit, but you can see that this is in the correct location, and it also has the top and bottom of my wall. Now, as I said before, we could just draw a simple polyline around the area that we're using, and I'll just do this real quick. And what we're doing is we're creating a boundary for this surface, so I can close that. I could go over to my surface name here that's brought in from Infraworks, AIW existing ground, and under definition I can add that boundary as an outer boundary. All right, all of these contours that are here, they did come in from Infraworks, which is fine, but all I'm concerned with are these contours here that were generated from the point cloud. All right, I hit OK, or I select that boundary, and now my surface, it's going to have a little bit of surface back here from Infraworks, but you can see that the contours do reflect the way that the pavement is graded. Now I will show you one other way to create a surface. If you want that lightweight surface instead of the actual point cloud information, I can erase my Infraworks surface, or here I erased it. Let's just turn it off for right now. So we'll just turn it and make it non-visible. All right. And I'll go ahead and I'll leave my boundary line there. That's fine. But I'll go ahead and bring in the points that we generated from the transverse lines. Now again, when I talked about this earlier, I said that this would be a lighter weight surface because it's not bringing in every single point from the point cloud itself. It's generating them on an interval like Civil 3D does, much like cross sections, and it pulls points, and we set it to every 2 feet along that line, that sample line, the transverse line, and populates a point file. So if you've ever built a surface in Civil 3D, it's very straightforward. You just select surfaces and create surface, and I'm just going to call this transverse. All right, and we'll leave it 2 foot, 10 foot background like the other contours were. And then we'll attach to that point file. So I could just select point files here, right click and hit add, and I can go out and attach to that point file. All right, so I can go here to LFE data. There's my transverse points Excel spreadsheet or Excel file. These points are in ENZ format. So I select ENZ, comma delimited, and you can see a preview here, easting, northing, and elevation. I simply hit OK, and it generates my surface for me. Now the contours look pretty good. It is a much lighter surface. And again, these were sampled every 25 feet, so you could actually go every foot if you'd like. And it's still going to be less points than what was generated inside the Infraworks model for an existing ground surface from that point cloud. So it would, Civil 3D will run better. It won't tax the machine near as hard, and you can get it depending on the road conditions and what you're trying to do. This might be a surface that you could use for design. So just a couple different ways that you could bring that design data in from Infraworks that was generated from that particular point cloud. So that is the LiDAR to design workflow. I hope you enjoyed the videos and have a great day.